Hi friends, welcome to CSE PEDIA. Today we're going to discuss about minimization of deterministic finite automata or minimum state DFA. Okay, so before going to this actual concept, here we need to check for the given states. In that we need to check for the final states. So the final states are made as one set and the remaining states are made as another set. Now, keeping final states apart, we need to check the different states and we need to compare each state with another state, and if at all any final state comes, that comes to our set. So this is minimization of deterministic finite automata. So before going to actual concept, let us take an example of DFA, and this is the complex problem we are taking to solve this minimum state DFA. First, let me draw that given DFA. Okay, so if you see carefully, this is a given deterministic finite automata. Now, in this given DFA, we have only one final state Q2, right? And we have from Q0 to Q7. So out of Q0 to Q7, we have only one final state. So we'll have that one final state in one set and the remaining all states in another set. So before doing that, let us construct a transition table for the given finite automata. Yeah, from the given deterministic finite automata, we construct a transition table for this. So the state or input, the inputs are 0 and 1. We have 7 states, right? 8 states, Q0 to Q7. Out of this, we encircle Q2 because as we know that Q2 is my final state, right? So what I'm going to do here is, so we'll make this as a 2 sets. So we'll call it as phi 0, that 0th partition. So Q2 is your final state, right? So Q2 is one set, and from Q0, Q1, Q3, Q4, Q5, Q6, Q7 is another set. So how to do this problem here? First, we need to check the final state. So we can have more than one final state, that's not a matter. So the one final state or two final state, that doesn't matter. A final state is one set and the remaining states are another set. So let us divide into two sets here. So if you see carefully, Q1 of 0 equal to F. As I said that we'll make final state as one set and the remaining all states are another set. So Q2 of 0 equal to Q minus Q1 of 0. So the given states are Q0 to Q7. Out of that, Q2 is my final state. So I will make final state as one set and the remaining all states is another set. So phi 0 becomes, Q2 becomes one set and the remaining Q0, Q1, Q3, Q4, Q5, Q6, Q7 becomes one set. So we cannot partition Q2 further. Why? Because as we know that Q2 is my final state, we can't partition Q2 further, right? Now I should consider the one set, that is Q0, Q1, Q3, Q4, Q5, Q6, Q7. So Q2 is final set, we can't partition that. So we'll take the remaining set and we'll compare each one with another one. That means I should compare Q0 with Q1, I should compare Q0 with Q3, I should compare Q0 with Q4, Q0 with Q5, Q0 with Q6 and Q0 with Q7. So let us compare that. So I am taking this set. Now I should compare Q0 with Q1 first. Okay, so Q0, Q1, and my inputs are 0 and 1. So Q0 on 0, I will get Q1, Q0 on 1, I will get Q5. So you can verify this in your transition table. Next, Q1 on 0. So what I will get here? Q6, Q1 on 1, Q2. Now I should see the vertical side, not horizontal, I should see vertical. I should see vertical Q1, Q6. So Q1, Q6, as we know that this Q1, Q6 belongs to the same set, but see here Q5, Q2, vertical Q5 and Q2. As we know that Q2 is a final state and it belongs to another set, so it is not one equivalent. Understood? So what we need to check here, we need to check vertical. If if both 2 belongs to the same set, the above given set, then it is one equivalent. If any one of belongs to another set, then it is not one equivalent. Now we compared Q0 with Q1. Next we should compare Q0 with Q3. My input is 0, 1. So Q0 with Q3. So Q0 on 0, Q1, Q0 on 1, Q5, Q2, Q6. So as we know, Q5, Q6 belongs to this set, but Q1, Q2 belongs to another set, right? So it is not one equivalent. So you understood the process. Next, Q0 is compared with Q4. Sorry, Q0 is compared with Q5. Zero, 1. So Q0 on 0, Q1, Q5. Next, Q4 on 0, Q7, Q5. Right? So Q1, Q7 belongs to same set. Q5, Q5 belongs to same set. So it is one equivalent. That means I can consider this state. Okay. Now Q0 is compared with Q5. So Q0 on 0, Q1, Q0 on 1, Q5, Q5 on 0, Q2, Q5 on Q6. So first I have Q2 here. So Q2 is another set, right? So it is not one equivalent. So if it is one equivalent, just give a tick mark in this so that we'll get a clear idea. Next, we need to check Q0 and Q7. Q0, Q6, sorry. Q0, Q6. 0, 1. So Q0 on 0, Q1, Q5, Q6, Q4. So Q1, Q6 belongs to same set, this one, and Q5, Q4 belongs to the same set. So it is one equivalent, right? Now Q0 is compared with Q7. Q0 is compared with Q7. Inputs are 0 and 1. So Q0 on 0, Q1, Q5, Q6, Q2. So this Q2 belongs to another set, right? So it is not one equivalent. So how many one equivalents I got here? Q0, Q4, this one, and Q0, Q6. So this given set is divided into two, which is one set is for one equivalent, one set is for not one equivalent. So what are my final sets here? So my final sets are Q0, Q4, Q6. How we got this? This is Q0, Q4. I wrote like this. This is Q0, Q6. Q0 I already there, right? So Q6. So Q0, Q4, Q6 is one set. So what are the remaining here? Q0 is over. Q1, Q3, Q5 and Q7. So Q0, Q4, Q6 is one equivalent set, and Q1, Q3, Q5, Q7 is another set. So total I have how many sets here? 3 sets. One set is Q2, which we already divided. This is a final set. Another set is Q0, Q4, Q6. Another set is Q1, Q3, Q5, Q7. Now Q2 we can't divide it further. Next we have 2 more sets here, Q0, Q4, Q6. So again we can do the same process. Q0 is compared with Q4, Q0 is compared with Q6. While doing this one, we can check for other sets. If any one of these sets belongs to this one, it is not 2 equivalent. If any this set belongs to this one, it is not 2 equivalent. Okay, after this set is over, we will check for this set, and these two becomes outers. This is inner set. These are outer sets. So while comparing this, if we got any of these sets, then it is not one equivalent. So in this way, we divide all the sets. So what we need to check here is our sets can't be divided further, so that our minimization is over. Now let us take Q0, Q4, Q6 and we'll divide this. Q0, Q4, Q6. So Q0 is compared with Q4 with input 0 and 1. So what we got here? Q1, Q7, Q5, Q5. Next, Q0 is compared with Q6 with input 0 and 1. So what we got here? Q1, Q6, Q5, Q4. Right. So Q1, Q7. So in this set, Q0, Q4, Q0, Q6. So what we got here, Q0, Q4 is not one equivalent. Why? Because this Q1, Q7 or Q5 is another set. So it's not two equivalent. One equivalent is already over, right? This is the second process. It's not two equivalent. Now Q1, Q6 and Q5, Q4. So Q5, Q4 is also one set. So it is also not one equivalent, right? So now we can't divide it further. So what sets we got here? Q0, Q4 is one set. Okay, comma. Here Q0 is already over. What is the remaining one? Q6. So Q6 is one set. Next, we said that we are going to compare another set. So what is that another set here? Q1, Q3, Q5, Q7. Okay. So the another set is Q1, Q3, Q5, Q7. So first Q1 is compared with Q3. Next Q1 is compared with Q5. Q1 should be compared with Q7. So Q1, Q3 with inputs 0 and 1. So what we got here? Q1, Q3, Q6, Q2, Q2, Q6. So this Q6 and Q2, Q2, Q6 doesn't belong to this set. It belongs to other sets. So this is not O equivalent. Cancel. Next, Q1 is compared with Q5. Inputs are 0 and 1. So Q1 on 0, Q6, Q2, Q2, Q6. So Q6, Q2, this belongs to another set. Q2, Q6 also belongs to other set. So it is not one equivalent. Now Q1 is compared with Q7. Q1 is compared with Q7, 0, 1, right? So what we get here? Q6, Q6, Q2, Q2. So Q6 is another set and Q2, Q2 is different set. This is also not one equivalent. So how to divide this right now? So we'll get Q1, Q7 is one sort of set and Q1 is already over. So Q1, Q7 is one set. Here Q1 is already over. Q1 is already over. What is the remaining here? Q3, Q5. Q3, Q5. So in the previous, what sets we got here? Q0, Q4 and Q6. So first we divided one set, right? That is your final state. So what is that? Q2. So how many sets we divided? 1, 2, 3, 4, 5. So we can't divide it further. So this is the final minimization of the given deterministic finite automata. So the minimized state is, so as we know that Q0 is my initial state, right? So Q0, Q4 becomes my initial state. And which one is the final state? Q2 is my final state. So Q2 becomes my final state. So we'll construct the given transition table. Why? Because these are the final sets for us. So Q0 is my starting state, right? So that's the reason my set is Q0, Q4, Q1, Q7, Q2. Q2 is my final state, Q3, Q5 and Q6. So Q0, Q4 on 0. So from the diagram we can get Q1, Q7. Okay. Next, Q0, Q4 on 1. Q3, Q5. So Q1, Q7 on 0. Q6. Q1, Q7 on 1. Q2. So Q2 on 0. Q0, Q4. Q2 on 1. Q2. Q3, Q5 on 0. Q2. Q3, Q5 on 1. Q6. Q6 on 0. Q6. Q6 on 1. Q0, Q4. Okay, now if we analyze the new table, the new transition table, and this one is the old transition table, right? So my state is Q0, Q4. So Q0 on 0, Q4 on 0. So you can see this table. Q0 on 0 is Q1, Q4 on 0 is Q7. So Q1, Q7, right? Next, Q0 on 1. So Q0 on 1 is Q5. Next, Q4 on 1 is Q5. But I can't write Q5. Why? Because if you see the set here, Q5 is associated with Q3. So I can't divide this set. So this is a single set. So I should write Q3, Q5. Even if I am getting only Q5, but Q5 is associated with Q3 as well. So Q3 comma Q5. Next, coming to Q1 comma Q7. So Q1 on 0, Q6. Q7 on 0, Q6. So Q6. See here, Q6 is a single set. So I got Q6. Next, Q1 on 1, Q2. Next, Q7 on 1, Q2. As we know that Q2 is also a single set. So I got Q2. Next, Q2 on 0. So Q2 on 0 is Q0, right? So, but I don't have a single set Q0. So Q0 is associated with Q4. So Q0, Q4. Next, Q2 on 1 is Q2. So Q2 is single, right? So I got Q2. Next, Q3, Q5 on 0. So Q3 on 0, Q2. Q5 on 0, Q2. So I got Q2. Next, Q3, Q5 on 1. So Q3 on 1, Q6. Q5 on 1, Q6. So Q6 is also a single set, right? So I got Q6. Next, Q6 on 0, Q6. So Q6 is a single set. I got Q6. Q6 on 1. Q6 on 1 is Q4. But Q4 is associated with Q0. So I got Q0, Q4. I hope you understood the new transition table. So from this new transition table, I will construct a transition diagram. Why? Because I have states here. Q0, Q4 is one state. Q1, Q7 is one state. So I should consider this as a single state. Q0, Q4 is a single state. Q1, Q7 is a single state. Q2 is a single state. Q3, Q5 is a single state. And Q6 is a single state. So I have 5 states. So depending upon this new transition table, I will draw a transition diagram. So from the new transition table, I constructed a deterministic finite automata, right? So depending upon that transition table, I constructed this. So these are my 5 states. Q0, Q4 is my starting state. Q2 is my final state. So this is minimization of deterministic finite automata or minimum state finite automata. So this is the most important concept and you can expect this question in every university. So I hope I clearly explained the concept of minimization of deterministic finite automata. And if you like my videos, please share my videos to your friends. And most important is, please do subscribe to my channel. Thank you very much.